Hello there and welcome back on a LabHub. So in this video we're gonna talk about the Bohr's model and especially about atomic physics. So what can we apply to atomic physics? We need a structure of the atom. We used to think that atom looks like this. There's protons, neutrons, negative, positive charge, something like this. But atom, according to the Bohr's model, doesn't work like that at all. We got a core of the atom with a positive charge. And we got some circles around it. We'll talk about them later. Now, I want to remind you about a guy called Albert Einstein. And he suggested once that energy can be converted to electromagnetic radiation from atom. And this is exactly how the X-ray radiation works, because the X-ray radiation and radiation is a part of electromagnetism. We know it. But how it works? All right, according to the structure of the atom, we can say that here is a negative particle, electron, right? Right. And what happens when it emits? When it disappears, so it emits, evaporates, it doesn't matter. It goes as a photon. It goes as a photon, a massless particle, part of the light, something like this. And to calculate its energy, we need to dive deeper into the structure of Bohr's model. So, Niels Bohr answered this by model of atom. He answered what? He questioned if atoms have positive charge and photons and negative electrons, why do they remain stable? Like they should attract each other, like this, ain't it? So that's how this model was suggested. And these circles are energy levels. Energy level 1, energy level 2, energy level 3, 4, and way more. They're almost infinite, I like to say. We can continue them as we want, but it really relies on what particle we use, which atom. So, potential energy of electron is also quantized. It means electron, a negative charge electron, can have any energy, but it's able to inhabit at certain energy levels that influx and fixed distances from core. You see, fixed distances from the core, they're the same. So each type of atom has unique energy due to unique number of photons. So we got, for instance, 2 photons here, 3 photons here, 1 photon here, and so on and so on. And each atom, ferrum and coprum, they all have different structure of atom. And, important point, let's draw it again. We can say that electron can travel on these layers, like on these stages. When photon can either join an atom structure, or it can leave the structure. How does it work? We got a negative particle here, right? Electron. So when it emits a photon, it goes in one stage down, right here. So now, the electron, this one, ain't here anymore. He's on the stage 1, right here. And if another electron gets a photon, right? If an electron gets a photon, it rises. It goes on the next stage. And therefore, we can finally say and estimate one of the most important equations. The delta electron, energy of electron, change in it, equals energy of photon. And so on and so on. So we see some electron changing at its stage where it's located. We can see that energy changed. It's an energy with one, a photon evaporated. And for hydrogen atom, the energy levels depend on Rydberg constant. And this constant looks like this. 2.179 times 10 in negative 18 joules. And therefore the given equation for it. Energy of electron equals to negative RH divided by n squared. N is amount of stages in the atom, like N1, N2, N3, and so on. Or we can modify it and we can change in energy level then. So just you see the formula, and this is for electron, and now we will find and we'll estimate an equation for change in electron energy. Change in electron energy equals to negative RH times 1 divided by n final squared minus 1 divided by n initial squared. What does it mean? If we had an electron on a stage, for instance, 2, and the another stage it got on, it was a stage number 1. So we use its final stage number 1, right? And as initial stage number 2. And then we can find a change in electron's energy. So the last thing we need to talk about is electron transition. This is which particles can get on each stage of electron. There are only 7 layers of it. 4, 5, 6, and 7. 7, 6, 5, 4, 3, 2, and 1. So, all the stages, and important, and so on, they're like infinite. Right, in real physics they ain't infinite, but we can say now, theoretically, they can be infinite. It can be any amount. Theoretically, it's any amount. In practice, it depends on each atom in periodic table. So, there are a kind of particles that work on each stage called lumen. And there are also particles that pass almost through everything. Against, they don't pass further the second layer, Balmer. Then they stop at third stage, passing, and the last one is Bronknet. So as you can see, they can start on each stage of the atom. So we got an atom, 1, 2, 3, 4, 5. In any of them can start like this. For instance, 100. Why not? We're in theory. We're working on theory right now. So they all can pass from 100 stage, but they will stop in each stage estimated in this table. So Brockner will stop on the fourth. Pascal will start on the third one. Balmer will start on the second. And Lumen will start on the first. In that case. And the last thing you need to know is every element has a unique emission spectrum. And this is all you need to know about basics of atomic physics and especially about the Bohr's model. Thank you for watching this. Stay connected with the LabHub.